Okay, today's lesson is quadratics. Quadratics are better known as parabolas. The vertex form here, I always called it HK form because HK is the vertex and it's easy to remember. You have standard form, which is when you use the quadratic formula, and factored form, which you don't use very often, but it's very helpful because you can find the roots fast. This one you can find the vertex quickly, this one you can find the roots quickly, this one you can find the y-intercept. So depending on what you're looking for, it might affect the form you want. Okay, I'm going to let you read that chart. You can always refer back to it, which is what I'm going to do while I work these problems. And these are notes here on how to convert to go to polynomial form. You square the binomial and distribute like terms. This one, to go back to vertex form, you have to complete the square. To get x-intercept form, you have to factor it. Okay? To make this one into polynomial form, you multiply it out, and then you complete the square to get to vertex form. Okay, so let's work some of these problems. Vertex form, it asks for the zeros. Well, if you look up here at the chart, it says to set it equal to 0, and it says set it equal to 0 and solve. So 0 is equal to negative 2x plus 3 squared plus 10. I subtract 10. Divide by negative 2. Negative 10 divided by negative 2 is 5. That should be a 3. Take the square root. Remember, when you take the square root, you always put a plus or minus in front of it. And now you subtract the 3. So you end up with x is equal to negative 3 plus or minus the square root of 5. And you got both roots. If you had FOILed it out and combined it and used the quadratic formula, you'd get the same answer. Okay? Vertex is h and k. Remember that the formula up here says negative minus h. So this is a minus a negative 3. So your vertex is at negative 3, 10. The y-intercept, you let x equals 0. So I end up with y equals negative 2 times 3 squared plus 10. 3 squared is 9, so that's negative 18 plus 10 equals negative 8. So you're at 0, negative 8. That's the y-intercept. The min and max, well, remember it's a parabola. It's negative. It's opening down, so it's going to be a maximum. It's at the vertex. So the max y value equals 10. Sketch, well, let's see, we're at negative 3, 10, and negative 3 plus the square root is 5. That's less than 2, so it's going to be here and here. Whoop, done. Okay, polynomial form. Up here at the top, you want to find the zeros. So you set it equal to 0 and factor if you can. If you can't factor, use the quadratic formula. There's no factors of 1 that add up to 4, so we have negative b plus or minus the square root of b squared minus 4 times a times c over 2a. So you get negative, that's a 2. Negative 4 plus or minus, this is plus 4, so you get the square root of 20 over 2. Negative 4 plus or minus 4 times 5, so this is 2 root 5 over 2, which you can reduce to negative 2 plus or minus root 5. Do you have to simplify? When the directions say so, yes. Okay, the vertex is negative b over 2a, so I have negative 4 over 2, which is negative 2. You plug that into your equation to get the y value, so you get 4 minus 8 minus 1 is negative 5. So negative 2, negative 5. The y-intercept, you let x equal 0, and you get y is equal to negative 1. The max or min, again, it's a parabola. It's opening up because it's got a positive leading coefficient. So it's a minimum at negative 5. And if you're going to graph it, I'm at negative 2, negative 5. And your intercepts are here and here. All right, factored form. You have to remember how to factor with a leading coefficient. This is the way I was taught. You multiply the first term times the last. So you got x squared plus 5x minus 24. The factors of 24 that give you 5 are 8 and 3. So I have x minus 3 and x plus 8 because I need a positive 5 in the middle. Now since I multiplied by 6, you come back and divide by 6. Reduce your fractions. And then get rid of the denominator. So you multiply this, you get 2x minus 1, and you get 3x plus 4. Okay, so now it's factored. The vertex is still going to be negative b over 2a. Is that what it says up here? Oh, no, it says r plus r over 2. I'm going to use negative b over 2a. So you have negative 5 over 12, which is ugly, and you plug that in and get a y value that I didn't even do. Maybe I did. Let's see. I'm checking my answers for you. Let's see. Nope, I didn't even finish it. I don't care. The y-intercept, plug in 0 for x. So y equals negative 4. So I'm at 0, negative 4. It's opening up again. So you're going to have a minimum at whatever that value is your minimum. Put in your calculator, it'll give you an answer. And graphing it, it goes through positive 1/2 and negative 4/3. Those are the roots. Okay? It didn't even ask for roots. So let's put this in here. The roots are 1/2 and negative 4/3. Alrighty? So that was a really quick overview of using it. Refer back to the chart till you get good at it and have it memorized. And this one you can do, if you have it in this form to begin with, use negative b over 2a. So let's do some problems. Do all quadratics have an x-intercept? Why or why not? The answer would be no. Because it could have imaginary roots, right? Could be up here, whoop, whoop. No x-intercept. It's going to have y-intercept. All right, complete the square to put these in vertex form. All right, completing the square. This is the way I was taught. You have x squared plus 4x. You take the terms with x and you put a box next to them, and you have the constant, and you added a box here. You're going to subtract the box here. To fill in the box, you take half of this term, so 4 divided by 2, and square it. 2 squared is 4, so you put 4 here and 4 here. I add 4 there, subtract 4 there. Now this is a perfect square. You just forced it to be a perfect square. So this is x plus 2 squared. This is b divided by 2. You have negative 1 minus 4 is negative 5. So there's my equation in HK form, which is easy. Now your vertex is at negative 2, negative 5. This one gets a little trickier. You separate your x terms. So these guys are going to complete the square, and I'm going to subtract the box here. Before I complete the square, I have to factor out the 2. So I get x squared plus 4x plus my box minus 11 minus the box. Okay, this box, again, you take that term, 4 divided by 2, and square it. So 4 divided by 2 is 2, squared is 4. Now, I didn't add 4, though. I added 2 times 4. So I'm going to subtract 8 on this side. So now I have y equals 2 times x plus 2 squared minus 19. Remember, you have to factor it out. So the leading coefficient here is 1. And do your complete the square. Okay? So solve the following equations. Which method would be best to choose? Best choice, and why? Quadratic formula, factoring, completing the square, square root both sides. I don't know what the cheer is, so I just cross it out. No. Okay, I'll look at this. I'm going to try my method to see if I can factor it. Multiply this times here. So you get x squared plus 5x minus 24. The factors of 24 to give you 5 are 8 and 3. X minus 3 and x plus 8. The thing to remember is you multiply by 6, come back and divide by 6. That's the step most people forget. Okay, so now you have x minus a half, and you have x plus 4/3. They want you to solve it. You set these both equal to 0, so you have x minus a half equals 0, and x plus 4/3 equals 0. So you end up with x equals a positive 1/2, and x equals negative 4/3. Okay, this one, you set it equal to 0 first. 3x squared plus 5x minus 7 equals 0. If I do this, I get x squared plus 5x minus 21. There aren't any factors of 21 that'll give me 5. 3 and 7 are the only ones I can think of, and it doesn't work. So I'm going to stick with this, and I'm going to use the quadratic formula. So negative b plus or minus square root of b squared minus 4 times a times c over 2a, which is 6. I got negative 5 plus or minus square root. What's this? 12 times 7. 12, 7 is 84. And I'm going to add 84. 84 and 25 is 109 over 6. I don't know if that cleans up, but I'm not going to worry about it. Okay? And now I got my answer. What about the last one? Well, if I divide by 3, you get x minus 3 squared equals 9. And then you take the square root of both sides, and you get plus or minus the square root of 9. So x minus 3 equals plus or minus 3. X equals 3 plus or minus 3. So x is equal to 3 plus 3. And x is equal to 3 minus 3. And there's your answers. Okay? Depends on the problem. I always try factoring. I know most people don't like to factor, but do it. It works really nicely. All right? The worksheet that goes along with this is a little tricky. What I want to do, I'm going to take this problem, 3x squared plus 5x minus 7, and use complete the square, just change forms. Okay, so let's not make it equal to to 0. Let's just make y equals this. And I want to put it in vertex form. So I got 3x squared plus 5x plus a box minus 7 minus a box. Remember, you've got a plus box here and a minus box there. I got to factor the 3 out. So you get x squared plus 5 over 3x plus a box minus 7 minus a box. Now half of 5/3 equals 5/6, and then I square it. So you get 25 over 36. And then I have to multiply that by 3 for here. So 3 times 25 over 36. This goes in, 12 times? So this is 25 over 12. Now this is 3. You have x plus, what did I square to get that? 5 over 6 squared minus, and then you just have to do your math. 7 times 12 is 84. So you have negative 84 minus 25, which is 109 again. 109 over 12. That's just ugly. Okay? But I wanted you to remember that you have to factor the 3 out, and sometimes you get messy things. Whatever you square, that 5/6 to get here, is what goes there. All right, do your homework. Let me know if you have any questions.